I'm going to continue talking to you about the greatest integer function. You should have already watched the Khan Academy video. If you haven't, you need to go watch it because I'm assuming that you already have. I'm not reteaching those things. The first thing we're going to talk about is the evaluating section on your worksheet. And the first equation is the standard greatest integer function or stair-step function. It's just f of x equals the greatest integer less than or equal to x. And it wants us to find each value. So if you remember from the Khan Academy video, this is where he drew the number line and showed you how to calculate things. We're going to review it again anyway. So f of 7 equals the greatest integer less than or equal to 7. And 7 is an integer, so we're just going to find out that f of 7 equals 7. But for part B, f of 2.3, we want the greatest integer, or think number line numbers, that is less than or equal to 2.3. So I like to think of this as rounding down. We're just always going to round down if it's not already a whole number. So f of 2.3 is going to round down to 2. And that's our answer. Then for part C, we have negative 4.8. So f of negative 4.8 is equal to the greatest integer less than or equal to negative 4.8. And again, when we think about our number line, less than is to the left. So even though mentally you may think, oh, if I'm rounding down, I'm going to get negative 4. But that's incorrect because negative 5 is actually less than negative 4. So when you're looking at negative numbers, remember you're going to the left on the number line, not towards 0. So f of negative 4.8 is going to equal negative 5 because negative 5 is the largest integer that is less than negative 4.8. So let's look at number 2. It's a little bit different. In number 2, you're going to see that there is something inside of the double brackets that we have to evaluate before we decide on the greatest integer. So let's just go ahead and look at f of 9. Remember, all that means is that we are going to plug 9 in for x. We're going to substitute 9 in wherever there's an x. So this is the greatest integer less than or equal to 9 minus 5. So first we have to evaluate 9 minus 5. So this is going to simplify to be the greatest integer less than or equal to 4, because 9 minus 5 is 4. And then we know that 4 is already an integer, so the answer to this one is just going to be 4. So now for f of 0.5, that's going to equal the greatest integer less than or equal to 0.5 minus 5. So that simplifies to negative 4.5. And remember that when you round decimals, like when we're rounding down in decimals, we're rounding to the more negative side. So this is going to give us a negative 5 as our answer. And finally, f of negative 8.1 equals the greatest integer less than or equal to negative 8.1 minus 5. Ran out of room there. And negative 8.1 minus 5 is negative 13.1. And the greatest integer less than or equal to negative 13.1 is negative 14. Because negative 13 is greater than that, is greater than negative 13.1. So there are 3 more graphing problems for you to do, numbers 4, 5, and 6. And I want you to do those on your own, but I do want to give you a few pointers for those. First of all, I don't want you to be too concerned about domain and range on these. I did give you the correct answers for checking yourself, but that's not the most important part right now. But I do want to give you the values that I would like for you to use when you make your tables. For your tables on these, I want you to use the x values 0. Oh, sorry, that was not working. Here we go. 0, 0.5, 1, 1.5, 2, 3, and 4. And that will help you establish a pattern. And I also want you to recognize that like the things that you do to these functions are going to move them around. So the function that he showed you looked something, it had like stair steps and it was centered on the graph and it looked something like that. But this function, we added or we're subtracting 5. So it's going to move all of these things down 1. So your function for number 4 is going to be something like, oh wait, move down 5. See, I already had it messed up. It's going to look something like this. This is not perfect. It's not correct. But it's going to be down here somewhere because it shifts everything down 5. On number 5, I want you to use the same x values that I just told you about. And I put the parent function there, like the original function. But this function is going to move it to the right 2 because of that -1. And then it's going to also stretch it out by a factor of 2. And so what that means is like this line right here is going to move right 1. And then it's also going to, like the next point is going to be stretched out. Like instead of there being 1 between these two, there's going to be 2. So there'll be a line here, a line here, a line here. And you can see that this is just stretched out. So your function is not going to look exactly like the ones that he gave you. And that's okay. You just need to find those patterns and graph them. So like I said, this one, because of that 2, these are going to be 2 apart. So instead of a stair step like this, you're going to have a stair step like this. They're going to be steeper. And then on number 6, I want you to know that this +4 shifts our graph to the left 4 places. And this 1/2 is going to do something different. Instead of like spacing them apart vertically, instead of having your normal stair step, this graph is going to have steps that are wider. So they're going to be 2 units long because we're dividing by 2. So just keep an eye out for those things, and I want you to recognize that that's possible, because otherwise, whenever you're filling in your table, you may question yourself and wonder, is this actually right? Is this possible? Am I messing up? So I just wanted you to know that there are alternatives and how they might look. But I would like for you to go calculate and graph the last 3 functions and check your answers. Have a great day.